observe all the different things which are displayed on your screen. So see the helium filled balloons, metal fork and spoon, honey, milk, banana, paint, coffee, hard boiled egg, cardboard box, hot air balloon, wind, rain, water vapor, plastic yo-yo, swimming pool and steam. And tell me, what is common among all these things? When we see, we notice that all these things occupy some space, right? Wherever they are kept or wherever they are in your room, in your surrounding, whenever you see that they all occupy some space and they all have some mass. That is, when you lift, you feel their mass, right? All these things are called as matter. And in this video, we are going to understand the entire chapter, matter in our surroundings. So, starting with the definition, what is matter? So, as I just defined, anything that occupies space and have mass is called as matter. That means you too are a matter. I am also a matter. The phone or the laptop or the TV in which you are watching this video is to a matter, because all these things occupy some space and they have mass. So here it is clear that matter has two things, mass and they have volume. For example, this Rubik's cube, when we will lift it in our hand, we'll feel the mass of this cube and it occupies the volume also. How do we classify matter? If we talk about our ancient time, the ancient Indian philosophers used to classify matter in the form of basic 5 elements, and they were called as Panch Tattva. As you can understand, Panch means 5 and Tattva means things. According to our ancient Indian philosophers, they said that all the matters were just made up of 5 basic elements, Panch Tattva. These 5 basic elements included the air, which is in our surrounding, the earth on which we are right now, the fire, the sky, and the last one is water. Air, earth, fire, sky, and water. These are the 5 basic elements of which all the matters are made up of. This is what the ancient Indian philosophers gave the idea of. And you know what? Later on, the Greek philosophers had arrived at a similar classification of matter. Okay, this is what happened in the ancient times. What about the modern day classification? How do we classify matter in today's time? Do we follow the same logic? No. In today's world, we classify matter based on 2 different properties. One is based on the physical properties and the second one is based on its chemical properties. And you know what? In this chapter, we are going to discuss about the classification based on physical properties. The chemical properties are going to be discussed in the later chapter of class 9th only. So let us classify matter based on physical properties, right? So there were 2 groups of people. Group 1 used to say that matter is continuous, like a block of wood. So when we take a piece of wood, it's a single piece of wood. It's continuous. That is what they want to say. Let us say this comb, this is made up of wood. This is a single piece of wood, and that is how matter is. It is just continuous. But the second group used to believe something else. They used to say that matter is made up of tiny particles. When tiny particles combine with each other, we see the matter in our surrounding. So they used to say that matter is made up of particles like sand. So when you take sand in your hand, you know that it is just tiny particles, but that what makes the sand. So this 2 group had different ideas. Now to clarify that which of the 2 groups is correct, there is one activity given in our textbook. In that activity, we have to take a glass or a beaker containing some water, and we have to mark the level of water which is inside that beaker. Then we have to add some sugar or salt in that water. Let us take salt for example. Okay, and then we have to dissolve it using a glass rod, or you can take spoon, mix it up, the salt will get dissolved in it. And then we have to check that is there any increase in the level of water. Obviously we are going to notice that there is no change in the water level, right? So what happened actually? If we added some matter, that is salt, in this water, it should increase the level, but there is no increase in the water level. That explains that water is made up of particles, and the salt is also made up of particles, small particles, and the particles of water have space between them. Okay, this water particles have space between them, and the particles of salt adjusted themselves in between the space. Hence, there is no increase in the level of water. So here we conclude from this activity 1.1, that is matter is made up of particles, and hence we come to the conclusion that out of these two groups, group 2 is correct and group 1 is not correct. Matter is made up of particles. How small are these particles of matter? Can we see the single particle with naked eye? To understand the size of the particles, there is another activity given in our textbook 1.2. In this activity, we have to take a beaker and fill 100 ml of water in it. And then we have to add some potassium permanganate in this water. Obviously, by adding potassium permanganate, it will get dissolved in water and the color of water will change to kind of purple color. In another beaker, we have to take around 90 ml of water and we have to transfer 10 ml of this solution to this beaker. So this was containing 90 ml and we added 10 ml more, so this became 100 ml. And yes, the color of the potassium permanganate will come here too. Then we have to take 10 ml from this and transfer it into another beaker containing 90 ml of water. Okay, the color is still transferred. Okay, then again we have to do the same to the next beaker and we have to continue this process and see that till what time the color stays there. We will find that the color will stay for so long. We just added some 2-3 crystals of potassium permanganate, but the color is still going on for a very long time. This explains us that just few crystals of potassium permanganate can color approximate, you know how much? 1000 liters of water. 1000 liters tank, you must compare it with the tank which contains 1000 liter of water. That much water can be colored by just few crystals of potassium permanganate. That explains that one crystal of potassium permanganate contains approximate millions of particles in it. Just one crystal contains millions of particles in it. So we conclude here that particles of matter, not matter of particles of matter are very small. They are small beyond our imagination. We cannot even imagine. Hence, we cannot even see a single particle with the help of our naked eye because they are very small beyond our imagination. Same activity 1.2 can also be done using Dettol instead of potassium permanganate. We'll notice that the smell of Dettol will stay for a long time. Now let us understand the characteristics of particles of matter. So through the activities which we saw till now, we have already concluded that particles of matter have space between them. So let us say these are small particles of any matter. They have some amount of space between them. The particles have space between them. This space can be more or less depending on different types of matter. What are the other characteristics to understand? Let us see activity 1.3. In that activity 1.3, let us go into a room. So here we are. We have to take some incense stick, agarbatti, and try to smell it. We will get the smell when we will take the incense stick closer to our nose, right? Then what we have to do? We have to lit the incense stick in one of the corner of the room, and we have to go to another corner. Let us say we are here. Okay, I am not here. Let us say these girls are here. Okay, And now we have to um, notice that, are we going to get the smell? Obviously, we are going to get the smell of this incense stick when we have lit it up. Okay, through the smoke, its smell will reach you, and these girls will be able to smell it. What does this activity explain? This activity explains that the particles of matter are continuously moving because they contains what, they contains energy. That energy is called as kinetic energy. Kinetic energy is energy due to the motion. When anything is in motion, it contains an energy which is called as kinetic energy. So when any object is moving faster, it contains more kinetic energy, and when an object is moving slower, it contains less kinetic energy. But yes, all the particles of matter contains energy which is called as kinetic energy. The particles of matter move faster in gaseous state than solid state. Because of this reason only, we were able to get a smell even when it was in solid state, but the particles were moving slower. Hence, we had to go closer to get the smell. But when it converted into gaseous state, when we lit it up, the smell came through a distance. Okay, it passed some distance and it reached to our nose. That explains that the particles of matter move faster when it is in the gaseous state as compared to the solid state. There is another activity which is 1.4. Take two beaker and add same amount of water in both of them. One of the beaker, add a drop of ink along the side of this beaker, and in another beaker add a drop of honey along the side of the beaker, and see that how much time it takes for the ink and the honey to uh, come down along the wall and get mixed into the water. Obviously, this is ink and this is honey. As ink is thinner than the honey, it will come faster and will get easily mixed in the water, but honey will take some time, right? So this ink got dissolved, but this honey is still struggling to come down and get mixed into the water. So what do we conclude through this activity? This activity explains us that the particles of matter are continuously moving, okay, but the rate of movement of particles differ from matter to matter. So the particles of the ink and the particles of the honey, they both are moving, but the speed of movement differ. The speed of movement in ink was faster, and the speed of movement of the particles in honey was slower. There is another activity 1.5. In that, we have to take again two beaker, fill water in both of the beaker in same amount, but the difference is this time in one beaker we have to take hot water and in another one we have to take cold water, and then we have to add, this is copper sulfate, which are blue in color crystals. Okay, add same amount of copper sulfate in both of them and let them get mixed with the water. We will notice that the diffusion will occur faster in the case of hot water and it will take some more time in the cold water. Diffusion. What does diffusion means, by the way? So the intermixing of particles of two different types of matter is called diffusion. Intermixing of two different types of matter. One matter, in the previous example it was the copper sulfate and the other was water. They got intermixed with each other. That is what called as diffusion. Intermixing of particles of two different types of matter is called diffusion. So in the activity 1.5, with the increase in temperature, the kinetic energy which we saw earlier that all the particles of matter has increases, because when we increase the temperature, that means we have heated it, and heat is a form of energy. So that energy of the heat get transferred to the particles of the matter in the form of kinetic energy. So when you heat something, the heat energy transfers into the particles in the form of kinetic energy. So the particles move more faster. Okay, and as a result, when there is more kinetic energy in hot water, the diffusion will occur faster, and here the diffusion will occur slower because it has less kinetic So till now we saw the two characteristics of particles of matter. Number one, particles of matter have space between them, and number two, particles of matter are continuously moving. The third characteristic says that these particles of matter also attract each other. They also attract each other. To understand this, let us see another activity. So let us make four groups. Okay, four different groups. In group one, the members of the group will hold each other like this idu mishmi dancers. Okay, like holding them each other like this way with their arms. Group 2 will hold each other with their hands like this, and group 3 will touch each other with the help of just their finger. They will touch just each other standing in a line. And what the group 4 will do, group 4 will run and will try to break this chain, different three chains. What do you think, that in which group they have to struggle a lot, and in which group it will be easier to break the chain? Obviously in group 1 it will be difficult for breaking the chain because they are holding each other in this manner, and in group 3 they are just touching each other with their fingers, so it will be very easy for group 4 to break this chain. In the same way, particles of matter attract each other. In some cases, the particles are attracted very strongly, like group 1. In some cases, it is intermediate, like group 2. And in some cases, the attraction is very weak, like group 3. To understand this, let us see another activity. 1.7. In that activity, we have to take this iron nail, we have to take chalk, and we have to take some rubber band. Then we have to take a hammer and try hitting this three things with the help of hammer. First we will try with this nail. Let us hammer once or twice. We'll see that not any major change will occur in the iron nail. In the case of chalk, when we will hit them, it will get broken like this. In the case of rubber band, again we will notice no change happening there. Okay, then we have to take a cutter and we have to try cutting this three things one by one. Iron nail will not be able to cut with the help of cutter. Chalk, if we will rub too much and will give time, the chalk may get cut. Then we have to take rubber band and try it. We will notice that the rubber band will get cut easily. What does this explain? This explains that the particles of iron are held together with a greater force, like the group 1 in that previous activity, how they were holding with each other. Similarly, the particles of iron, they are holding each other very strongly with the greater force than the particles of chalk and the rubber band, right? So particles of matter attract each other, and this attraction may be stronger, maybe weaker, maybe intermediate. It depends on different types of matter. So another activity is there, 1.8, in which we have to take a bucket of water and we have to cut the surface of water with the help of our finger. Okay, moving our finger in the water, we have to try to cut the surface of water. Will we be able to cut this surface? The answer is obviously no. We will not be able to cut. When we will pass our finger, the water again will stay connected with each other, right? This explains that the surface of water cannot be cut due to the force of attraction between the particles. The particles of water have attraction between them, which does not let them get separate from each other. So when we move our finger, again they get attached to each other due to the attraction and maintain their surface level. So point to be noted is that the strength of the force of attraction differs from matter to matter. Now we will see the different states of matter which exist in our surrounding. So we see that matter exists in three different states around us, that is solid, liquid, and gas, right? But what is the reason behind it? The difference is made because of the variation in the characteristics of the particles of which these three different states are made up of. Let us understand the solid state. So to understand, activity 1.9 is there. Take some things like, let us say, take a pen, book, needle, and a wooden stick. Then what? Take a paper and a pencil and put this four different things one by one on this paper and draw the outline of this four different things with the help of pencil. First taking the pen, then the book, then the needle, and then the wooden stick. What we will notice? We will notice that they all have a definite shape, because when we will draw the outline, they will have a specific shape, right? So we notice that they have a definite shape, they have their distinct boundaries, and they have fixed volume. Their volume is not changing with time. Then we have to hammer them one by one, pull them, or drop them. What we will notice? What will happen? They may break. Let us say if we hammer the pen, it may break, or the wooden stick may break. Okay. Will they diffuse into each other? Will they get mixed with each other easily? The answer is no, they will not. If we try to compress them, compress the pen or the wooden stick or the book, will we able to compress it? The answer is negligible. The book, at some extent, very less amount of compression can be made, okay, through our muscular force. So the compression is negligible. All this, all these tests explains this all are solids. So through these activities, we get to know the characteristics of solids. The number one characteristics is it has definite shape, distinct boundaries, fixed volume, negligible compressibility, are rigid. That is, it is difficult to change their shape. If we will try to change their shape, they may break. That is, they are rigid. What about rubber band, sugar, and sponge? Are they solid too? Rubber band. When you apply force on a rubber band, it changes its shape. But this change in the shape will stay till the time you are applying force on it. When you will remove the force, it will again get its original shape what it was before. Hence, rubber band is a solid. Sugar. When you transfer some sugar from a bowl to a dish to a glass, it changes the shape. It takes the shape of the vessel. But when you see the each particle of sugar crystals, that sugar crystal has a fixed shape. So sugar is also a solid. And if you take sponge, when you press it, right, it changes its shape. But that happens because in sponge there are pores in which air is trapped. So when you press it, the air comes out. Okay. As a result, it changes its shape. But when you will release it again, it will get the original shape. So a sponge is also a solid. That gives the conclusion to us that all these things are solid. Let us move to the second state of matter, which is the liquid state. For understanding liquid, let us see the activity 1.10. Take some water, some cooking oil, milk, and juice. Okay, and take containers of different shape and take, let's say, milk or water and fill this different shapes of container with water. This cuboidal one, this cylindrical one, and this is also a cylindrical one. We'll notice that the water will take the shape of the vessel in which it is poured, right? So that gives us the conclusion that liquid has no fixed shape. It will take the shape of any container in which it is poured. Now, next, what we have to take? Does the volume remain same? If we transfer it from this container to this container, then this container, it will change its shape. But what about volume? The volume will remain same. Let us say if we took 100 ml here, it will stay 100 ml here also, and it will say 100 ml here also. That is, the volume will remain same. So does the volume remain same? Yes. Does shape remain same? No, the shape changed. Then we have to take these four things and put little amount of all these four things on the floor. We will notice that they will flow on the floor. So that is, they all are fluid. When any matter flows on its own, that is called as fluidity, and the matter are said to be fluid. So these liquids are fluids. So here are the characteristics of the liquid. Number one is it has no fixed shape, that is they are not rigid, they changes their shape. Then they have fixed volume and they can flow, so they are fluid. Diffusion in liquid, again this word came, diffusion. We have seen this word diffusion before also. Yes, what was it? Try to remember it. Diffusion means the intermixing of two different types of matter is called as diffusion, right? So diffusion in liquid, let us see. uh, can a solid diffuse in liquid? Yes. Take sugar and put it in water, mix it up, diffusion will occur there. Liquid in liquid, yes. Take some lemon juice and put it in water, the lemon juice will get diffused in water. Gas in liquid, yes, that is also possible. As for example, take some soft drinks, okay, it contains water as the primary ingredient and CO2, that is carbon dioxide gas is there, hence it is called as carbonated drinks. So solid, liquid and gas, all these three, right, all these three can diffuse in liquid. In fact, if we talk about the life in water, the aquatic animals and plants get their essential oxygen and carbon dioxide through the water. The plants get the carbon dioxide and the fish get the oxygen, which are dissolved, that which are diffused in the water. And obviously the rate of diffusion in liquid is higher than that of solid. In liquid, any matter that is solid, liquid and gas will get much easily diffuse than something we are trying to diffuse in a solid substance. Okay, so rate of diffusion in liquid is higher than that of solid because the particles of liquid have more spaces between them to move freely as compared to the particles of solid. Let us talk about the third state of matter, which is the gaseous state. So here is a balloon seller who is selling balloon. Okay. Do you know that how many balloons can be filled through one single cylinder? The single cylinder which generally the balloon seller used at 5 to 6 feet one, from which he fills the balloon. Do you know that how many balloons can be filled through just one single cylinder? It actually depends on the size of the cylinder and size of the balloon also. So in general, the regular cylinder with this normal size of balloon can fill hundreds of balloon. It can be 500, 600, 700, 800. It is in the range of hundreds generally depending on the size of the cylinder and the balloon. So you know how much volume it takes in that cylinder. That space it takes is too less as compared to the number of balloons which can be filled through that single cylinder. And do you know that which gas is filled inside this balloon? It is the helium gas, which is lighter in weight. So when it is released, it floats in the air. But you know that there are news on internet about fire accidents happening due to the balloon because there are people who are also using hydrogen gas, which also float the balloon, but it is highly flammable gas. Hence, there are high risk of fire accidents when hydrogen is used instead of helium. So whenever next time you go in a fair and buy balloons, ensure 100% that it is helium gas and not hydrogen gas. So there is activity 1.11 in which you have to take three syringes of same size, okay, and you have to remove the pistons of all these three and keeping one as it is, put rubber corks on the ends of this. To understand about gas more, there is activity 1.11 in which you have to take three syringes without needle, okay, of same size, remove the piston of this three and close the end of this syringes with the help of rubber cork. In one there is nothing, that is just gas. In another fill some water. In third one put some chalk powder in it, okay, and put the piston back to its place and try to press this three, applying pressure. try to compress them. What do you think? In which of these three it will be quite easier to compress? Gas, water, or this chalk? We'll find that gas are highly compressible as compared to solid and liquid, because you will be able to compress a little bit in this gas one, in a little less in water, and very negligible in chalk. Okay, so that explains that gas are highly compressible as compared to solids and liquid. In fact, there are plenty of examples of compressed gas which we use in our day-to-day life. For example, the LPG gas, that is the liquefied petroleum gas, which we use in our kitchen to cook food. Then the oxygen gas cylinder, which is used in hospital to provide oxygen to the patients. Then the CNG, that is the compressed natural gas, which is used widely now in vehicles as a fuel. All these are examples of gases which are compressed and then used. By compressing gas, we can actually store a large volume of gas in a very compact space. That is the benefit of storing gas. So large volume of gas can easily be compressed into a small cylinder and can easily be transported. Now let us take a situation here. This man is cooking some tasty food in the corner of a street, and you are nearby that man. When he is cooking the food, you will notice that the smell of this hot food is reaching you very easily, even when you are a little bit far. For example, when you drive on a bike nearby from a Chinese shop, you get the smell of the Chinese food very easily, a strong smell. So, what actually happens is the particles of the food, when it is hot, have high amount of kinetic energy, as we know, because when temperature increases, energy from the heat get transferred into the particles of matter in the form of kinetic energy. So the particles move very easily and very randomly, right? So let us take the example here. This orange dots are indicating the particles of the smell of the food, and the white dots are indicating the particles of the air in our surrounding. So as these particles get mixed into the air, when the air moves, it takes the particles of the smell of the food also along with it, and when it will move, the smell will easily reach to you and you will get the smell of the food. So basically, this both are gas, and the gas diffuse in gas very fast. Okay, why? Because of the high speed of the particles, right? And a large amount of space is there. If we see the particles of the gas, they have huge amount of space between them, and they also have high amount of kinetic energy, so they move very fast, they have high speed, right? So gas will diffuse easily and faster in another gas. And gas also exerts pressure in whichever vessel or container it is stored. For example, that this container is having some gas filled in it. So the particles move about randomly at high speed. So these particles are moving at randomly at high speed, right? So the particles hit each other and also the walls of the container. So this particle will hit this particle, then this particle will hit this particle, and so on. They will hit each other and also on the walls of the container. So as a result, it will exert pressure. Because of the force exerted on unit area of the wall, it will create a pressure inside the vessel. This figure gives us the idea about how the particles of matter in the three different states are arranged. As you can see, this is a saucer which is a solid. Here the particles are very close to each other. Okay, the particles are arranged so close to each other that there is very little amount of space between the particles. In the figure B, it is liquid. Let us see, this is water inside the beaker. In the case of liquid, the particles have a little more space between them. Okay, the particles are a little bit far from each other as compared to solid. And in the case of gas, the particles are very far from each other. Okay, there is a huge space between two particles. So this is how the particles are arranged in these three different states of matter. Now the question is, can matter change its state? that is if there is a matter which is in solid state, can we change it into liquid state, or can we change the liquid state into gaseous state? The answer is obviously a yes, because we all have seen the three different states of water, right? The first one is, let us say, solid, which is ice, okay? Then liquid, as we have seen, water, and the gas as the water vapor. So these three are different states of water, okay? Solid, liquid, and gas. So yes, matter can change its state. Now let us talk about what are those factors based on which a matter can change its state. So the first effect we are going to see is the effect of change of temperature. That by changing temperature, the state of a matter can be changed. Okay. So here in this activity, we have to take an iron stand which is holding a thermometer. Here is a burner, and above the burner there is a beaker which is containing ice, and here is a glass stirrer. So we have to arrange the thermometer in such a way that the bulb of the thermometer gets in contact with the ice, okay? And we have to keep a eye on the thermometer reading, that what reading it shows. We will notice that when we will start the burner and the ice will start melting, we will notice that the ice will start melting at 0 degree Celsius, okay? Then we have to keep on heating the ice till the ice completely gets melted. So ice will change into water. At that time also, again we have to see the reading of thermometer. What do you think? What will be the reading of thermometer? Ice started melting at 0 degrees Celsius. Now the ice has completely melted, and it has changed into water. What should be the reading of thermometer? Shall it increase or what? So we will see that after the ice melts, the temperature still remains the same, that is, it will still be 0 degrees Celsius. What? Really? Here we continuously applied the heat. So, as per the logic, the temperature should have increased, right? Thermometer should have increased the reading from 0 degrees Celsius to above it. But after the ice has melted from ice to water, still the temperature will remain same, that is 0 degree Celsius. Okay, and then we have to constantly put the burner on and let the water get heat. We'll notice that after certain minutes the water will start boiling, and that time we have to see the temperature in the thermometer. It will show 100 degrees Celsius, that is, at 100 degrees Celsius the water will start boiling. It gets converted into vapor at the same temperature, and then as it will start boiling, the water from the liquid state, it will start getting converted into the gaseous state, that is in the vapor form, right? But that time too, the temperature of the water will remain same, that is 100 degree Celsius only. Okay, so what happens actually? Let us see that why when ice melted and converted into water, there was no change in the temperature, that is it remained 0 degrees Celsius. Let us see. So here is ice, okay, which is the solid form of water. So obviously this ice is made up of what? This ice is made up of particles, and we know that these particles contain kinetic energy. Now when we put it on the burner and heat it, we are actually giving energy to the particles of this ice cube, because heat is a form of energy. So when we are heating it, the heat energy is getting converted into kinetic energy. Okay, the energy from the burner is passing to the particles of this ice in the form of kinetic energy. Already the particles were containing kinetic energy, but now the kinetic energy has increased. As a result, the solid will start melting into liquid. Why? Because as the kinetic energy increases of the particle starts moving very fast, very quickly, due to that high energy, and they break the attraction between the particles and start moving freely, and hence the solids melts into liquid. Okay, and this temperature at which a solid melts to become liquid at the atmospheric pressure. The atmospheric pressure means the normal pressure which is generally available everywhere in the air. atmospheric pressure is called as its melting point. So the minimum temperature at which solid melts at the atmospheric pressure is called its melting point. So the melting point of ice is 0 degree Celsius because it started melting at 0 degree Celsius. So the melting point of ice is 0 degree Celsius, and if we convert this 0 degree Celsius into Kelvin scale, Kelvin unit, which is the SI unit of temperature, it will be 273.15 Kelvin. Okay, so approximate we will take it as 273 Kelvin. So melting point of ice is 0 degree Celsius, or also we can say it is 273 Kelvin. Okay, so this process in which a solid changes into liquid is called as what, it is called as fusion. So here fusion happens. So the explanation of why there is no change in the temperature lies here only, that here when we are applying this heat energy, that heat energy is getting converted into kinetic energy, and the particles of the ice are using that energy to change their state from solid state to liquid state. Okay, particles are getting energy and they are moving very fast and quickly, and hence they are getting separate from each other, and solid is changing into liquid. So no energy is utilized to increase their temperature. All the energy is utilized by the particles to get separate from each other and change the state. First the state will change, and then if you will continuously supply the heat, then there will be change in the temperature, then the temperature will increase. But first what will happen? First the state of the matter will change from solid to liquid, and hence there is no increase in the temperature. So the heat initially which we supplied during the change of state, the change of state from solid to liquid, here that temperature remaining constant, it is called as latent heat. Latent means hidden. So we were supplying heat, but there was no change in the temperature. That heat, that particular heat is called as latent heat, because that heat remained hidden. Okay, so as a result, when it is ice, it converted into water, and when water converts into steam, in both this separate process, the temperature will remain same. Here it will remain 0 degrees Celsius, and here it will remain 100 degrees Celsius. The temperature will remain same. So the amount of heat energy that is required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Take the example of 1 kg ice. If we heat and convert into liquid, the temperature in both the case, as we know, will remain same, 0 degrees Celsius, right? So that heat which we have given to this ice of 1 kg to convert into liquid, that is water, that heat is called as latent heat of fusion. Okay, if you talk about the energy of ice, and then it is getting converted into water, which will have more energy? Obviously water will have more energy than ice, because the particles of water has got the energy from the heat in the form of kinetic energy. So the particles of water will have more energy than the particles of ice. And in the same way, we can understand why there is no change in the temperature when water gets converted into vapor. So this is liquid water. Obviously, here also the particles have kinetic energy. When we will heat, what will happen? Again, the heat energy will get converted into kinetic energy. So the particles will get more energy. The particles will start moving more faster now. Okay, as continuously energy is given through the heat energy. Okay, so at specific stage what will happen? The particles will now have more energy to break free from the force of attraction with each other. So these particles now will get that much amount of energy that they can break the attraction between each other and get converted into the gaseous form. So liquid changes into gaseous form then. So the temperature at which a liquid starts boiling at the atmospheric pressure, that temperature is known as the boiling point. And boiling is a bulk phenomena That means that later on we will also study evaporation. That is not a bulk phenomena. Boiling is a bulk phenomena. That means what? When you take a vessel filled with water and you heat it, the whole liquid will all together in bulk will reach the boiling point, and you will notice that the bubble will start coming from the bottom of the vessel and coming at the top, and at that time the liquid starts converting into the gaseous form, that is the vapor form. So the whole bulk of the water, all the particles reaches the boiling point, and then it uh, converts into gaseous form. That what it means when it is written that boiling is a bulk phenomena. Okay, then what is the boiling point of water? It is 100 degrees Celsius. That is, if we convert it into Kelvin, it will be 100 plus 273, that is 373 Kelvin. So here we understand that how can we convert degrees Celsius temperature into Kelvin scale. Just add 273 to it. So 100 degrees Celsius means 100 plus 273, that is 373 Kelvin. And if you want to convert Kelvin scale into degrees Celsius, so minus 273, that is 373 minus 273. If you will do, you will get again 100 degree Celsius. So now in the same way we can define the latent heat of vaporization, that is the amount of heat energy that is required to change 1 kg of liquid into gas at atmospheric pressure at its melting point is known as the latent heat of vaporization. That is, if we took 1 kg of water, if we heat, boil it and convert into vapor state, the energy that will be required, the heat that will be required will be called as latent heat of vaporization, because throughout this process the temperature of this system will remain same. Both will have 100 degrees Celsius, that is 373 Kelvin. And if we compare the energy, we know that the steam particles will have more energy in the form of kinetic energy. So comparatively the energy of steam particles will be more than the particles of water. Okay, so the state of matter can be changed, and we saw that it can be changed by changing the temperature. Solid changes into liquid by heating. Liquid also changes into gas again by heating. If you want the reverse process, cool them down. If you cool a gas, it will change into liquid. If you cool it further, it will again become solid. Let us see activity 1.13, in which we have taken this funnel which we have put inverted on a china dish, and in this china dish there is camphor, which is called as kapoor in Hindi, which we burn during aartis, and we have to burn it, and here we have put cotton plug so that the hot air can go out easily. So when we will heat it, what we'll notice that the camphor, which is initially in the solid state, will with time disappear from there. That means it will directly get converted from solid state to gaseous state without going into the liquid state. We will not see the liquid state. Solid camphor will disappear, that means it will get converted into gaseous state. And after certain time, the camphor will again get deposited on the walls of this funnel in the form of solid again. Camphor from solid state directly changes into gas state. It again deposits in solid form on the walls of the funnel, and this change of state directly from solid to gas without changing into liquid state is called as sublimation. Okay, and a change of state directly from gas to again solid form, it is called as deposition without going into the liquid state. Okay, so this is the definition of sublimation and deposition. So here till now we have understood that change of temperature plays a role in changing the state of matter. Now let us see how the change of pressure can also change the state of matter. So here is a gas in this cylinder, and as we know that the particles of gas are very far from each other and they are moving with a high amount of kinetic energy. If with the help of piston, if we put pressure on this gas, what will happen, that the particles are forced to come close to each other, and when particles come close to each other, it will get converted into liquid form. So By increasing pressure and decreasing temperature, a gas can be liquefied. We can change the gas into liquid state. You must have seen fire extinguisher here and there wherever you go, hanging on the walls for safety purposes. There are types of fire extinguisher which contains solid carbon dioxide, that is CO2, which we generally hear about in the gaseous form. It is present in the cylinder in the form of solid under high pressure. Okay, and if we decrease the pressure to 1 atmosphere, it gets converted into gas state without changing into liquid state. We know that carbon dioxide gas is used to extinguish fire. It can extinguish the fire. So inside the cylinder it is in the solid form, but when we will use it outside the bottle, there is the pressure of 1 atmosphere. 1 atmosphere pressure is the pressure which is generally available at room temperature, at normally all the place. So when it comes out, the pressure gets reduced to 1 atmosphere and it directly changes from solid state to gaseous state and helps in extinguishing the fire. Hence, solid carbon dioxide is also known as dry ice. The word dry is used because the solid carbon dioxide directly changes into gaseous state without going into the liquid state. So sublimation happens here. And ice, because solid carbon dioxide looks like the normal ice which is made up of water. So that is why solid carbon dioxide is known as dry ice. Thus both the things plays a role to change the state of matter, that is temperature and pressure. Both determines the state of matter. Let us see what are the name of the different processes which are involved in the change of the state of matter. When solid changes into liquid, as we have already seen, it is called as fusion. When you put water again in the freezer and you get ice, you do the process which is called as solidification. When you heat the water, boil it and convert it into steam, that process is called as vaporization. And when gas again changes into liquid, that is called as condensation. When solid changes into gas, it is called as sublimation, and when gas changes into solid, it is called as deposition. Now let us say we are in this room in which there is a bucket full of water and by mistakenly this water spilled down on the floor. Will this water stay here forever if we will not clean it up? No, right? It will disappear automatically with time. This process is called as evaporation, where we have not boiled the water to get it converted into vapor state. Automatically, the water which was in the liquid state, with time, slowly and steadily got converted into gaseous state. This process is called as evaporation. So, evaporation, as we can see in our day-to-day life while drying out the washed clothes also, the clothes contains water, but we don't need to boil the clothes to remove the water out of it. We just put it in the sun and with time the water from the clothes gets out. Okay, that is again evaporation occurs there and the clothes dry. So this phenomena of change of liquid into vapor at any temperature below its boiling point of water, we know it is 100 degrees Celsius, but in both the examples which we saw just now, here we saw that the change of liquid to gas will occur below the boiling point, below 100 degrees Celsius, liquid getting converted into vapor. That is called as evaporation. So let us understand how this evaporation process occur. So here is some amount of water and here are those particles which are at the surface of the water, and there is this very tiny fraction of the water particles which have higher amount of kinetic energy. These are those particles which are at the upper surface of the water. Okay, so what will happen due to this high amount of kinetic energy which is possessed by the particles at the surface of water? They break away from the force of attraction with other particles and hence converts into vapor. Now, from where do these particles at the surface got energy? Here we are not boiling the water, So from where do these particles got energy? These particles got energy from the surrounding. From the surrounding, wherever this water is spilled on the floor, from the surrounding, the water particles which are at the outer surface will get energy, and due to the high kinetic energy, they can break the force of attraction with other particles and hence converts into vapor state. Okay, so this is how evaporation occurs. Now let us see activity 1.4, by which we can understand that what are the different factors on which evaporation depends. So here we have to take a test tube in which we have to fill, let us say, 5 ml of water, and we have to keep this test tube uh, under a fan or at the open window. Okay, uh, secondly, we have to take a, let us say, saucer, and same amount of water, that is 5 ml of water, we have to fill in this too, and that too we have to keep either below the fan or at the open window. And third, we have to take again a saucer, fill it with water, same amount of, and put it in this cupboard. Open it and put it in the cupboard. Okay, so it is in the cupboard. Now we have to record the room temperature when we have put this here, and we have to see that in which of these three cases the evaporation will occur the fastest. What do you think and tell me whether it will be in the test tube, in this saucer, or in that saucer which is in the cupboard. Evaporation will occur in this case, right? Yes, you are right, it will occur fastest in this saucer. Now let us see what are the factors because of which evaporation occur fastest here. So the rate of evaporation increases with, number one, an increase of surface area. So here in this two case we can see that the surface area of the water in the saucer is much larger than the surface area of water in this test tube. Okay, more number of particles are exposed to air, hence they will get more kinetic energy. The number of particles which will get kinetic energy will be more, and hence evaporation will occur faster here. Okay, so surface area plays a role. Secondly, the rate of evaporation also increases due to the increase of temperature. As we know that when temperature is increased, the particles get more kinetic energy from the heat energy, and when they have more kinetic energy they move more faster, and hence evaporation will occur faster. The rate of evaporation also increases with increase in the wind speed. So when the liquid gets evaporated and gets converted to gaseous state, if wind comes there, it takes away the particles away from that place so that new particles can get convert from liquid to gaseous state. The rate of evaporation also increases with the decrease in humidity. Now what is humidity? Humidity means the amount of water vapor present in the air. The air which is around us can hold a limited amount of water vapor only. Okay, not more than that. Let us say here is a room. In this room there is air, and this air can hold a fixed amount of water vapor only in the air, not more than that. So let us say this blue dots are indicating water in the form of vapor. So if already in the room there is too much of water vapor, too much of humidity is there in the air, evaporation will occur with difficulty because already there is traffic jam in the air between the particles of water vapor. So new particles will not get space to make their space. They will struggle for it. So evaporation will become slow if there is already too much humidity in the air. So we saw that the rate of evaporation increases with increase in first of all surface area, secondly increase in temperature, third increase in wind speed, and fourth decrease in humidity. Three things increase, one thing decreased. Have you ever put acetone on your hand? If yes, you must be knowing that it feels very cool on your hand, on your palm, when you put that acetone. And at the same time, that acetone gets evaporated, it disappears from there, and you feel cooling effect on your hand. Now let us understand that how evaporation causes cooling. So here is some water which is, let us say, on the floor. with time we know that evaporation will occur here, that is the liquid will get converted into gaseous state. Let us understand how it happens. So the particles which are on the surface of this water, they actually get energy from their surrounding. So this surrounding, that is, let us say it is a floor here, the floor will supply energy to the particles of this water. So when these particles will get energy, that energy will be in the form of kinetic energy. So when the kinetic energy of these particles increases, they move more quickly, more faster, and has the ability to break the force of attraction between them and can get into the gaseous form. But yes, who is supplying this energy to these particles? The surrounding. So when this surrounding supplies energy, means there is loss of energy. So as there is loss of energy, there is decrease in temperature in the surrounding. Okay, so due to the loss of the energy, there is decrease in the temperature in the surrounding, and hence decrease in temperature leads to the cooling effect. So when we put the acetone on our hand, it gets evaporated because the particles get energy from the surrounding, that is from our palm, and as there is loss of energy from our palm, there is cooling effect on our palm. So that is how evaporation causes cooling. And because of this reason, on a sunny day we sprinkle water around our house and on the roof of our house, so that evaporation occurs here and it creates a cooling effect. Also, you must have heard that it is recommended that we should wear cotton clothes in summer. It is comfortable, right? So the reason behind it is that during summer, because of too much of heat outside, our body tries to maintain the required temperature in the body. As a result, it produces sweat. So in summer we produce so much of sweat. So that sweat, when it gets evaporate, it will make a cooling effect on our body. So as a result, if we will wear cotton cloth, the cotton is a good absorber of water, so it will absorb the sweat from the body and it will expose it to the air. As a result, it will get easily evaporate and hence we will feel cool. So that's the reason why it is recommended to wear cotton clothes in the summertime. So cotton is a good absorber of water. Also, you must have noticed that if you take a chilled, not chilled also, but cold water in a glass, after a moment, you will find tiny water droplets on the outer surface of the glass. From where does this water come? So actually, it is not peeping out obviously from inside the glass. Around the glass, where there is air, in the air there is humidity, that is water vapor in the gaseous state. When the water vapor comes in contact with this cold glass, it loses energy, and as it loses energy, it gets converted into liquid state again. That is, this process is called as condensation. As we have seen earlier, gas changes into liquid state. So due to the condensation of the water vapor in the air, the tiny water droplets come on the surface of the glass. So as a result, this chapter is completed in this video. I hope that you have understood all the concepts which I have explained in this specific video. What I will recommend you is that after watching this video, you yourself read the entire chapter from the textbook, so that it will get revised once again, and attempt the in-text questions and exercise questions by yourself, by your own knowledge, through this video which you have got and through the textbook which you will again revise. And that's done. You are done for this chapter, and you can attempt any question if asked in the examination and score the full marks from this chapter. See you in the next video.